In this video, we will introduce the concept of weak bases. By now, we're all familiar with the concept of electrolytes and non-electrolytes. Electrolytes consist of ionic compounds, which dissociate into their individual ions when dissolved, and the presence of these ions causes water to conduct electricity. Non-electrolytes do not conduct electricity when dissolved in water. That's because they include covalent compounds, which, even though they do dissolve in water, they do not dissociate into ions. Electrolytes consist of ionic compounds such as sodium chloride and sodium hydroxide, as well as acids. And non-electrolytes are generally covalent compounds, which include sugars, alcohols, and even certain gases that we can dissolve in water. We can further classify electrolytes as either strong or weak. Strong electrolytes will dissolve completely in water, producing stoichiometric equivalents of ions. And that's represented here on the left with the reaction of hydroiodic acid in water. You notice that it has a single arrow going from left to right. This indicates that this reaction goes to completion. However, weak electrolytes, although they still completely dissolve in water, will only partially dissociate into ions, therefore producing fewer ions and conducting electricity poorly. The reason for this partial dissociation of ions in a weak electrolyte, such as hydrofluoric acid, is because the ions have a high enough affinity for each other to recombine to a certain extent, which is why weak electrolyte reactions have this double arrow, this reverse arrow, in addition to the forward arrow. So strong electrolytes include all ionic compounds, the 7 strong acids, and weak electrolytes include any acid that is not among the 7, such as hydrofluoric, carbonic acid, and organic acids known as acetic, citric, and benzoic. And then non-electrolytes include covalent compounds, such as sugars, alcohols, and certain gases. However, we want to talk about weak bases. To understand what a weak base is, we need to go over our concepts of acids and bases. One definition is the Arrhenius acid. This is a substance that dissociates into water to form hydrogen ions. An Arrhenius base is a substance that dissociates into water to form hydroxide ions. Now here, sodium hydroxide is a very good example because it's an ionic compound. It will dissociate and dissociate completely into sodium ions and hydroxide ions, therefore increasing the concentration of hydroxide in water. That's the definition of a base. But a slightly different definition is the Brønsted definition of an acid to base. Now the Brønsted acid is pretty much the same thing, except now we're defining it as something that reacts with water to produce hydronium ions, which is the same thing as a simple hydrogen ion in water, except now we're showing it actually attached to the water molecule. Now, a Brønsted base is a substance that will react with water to form hydroxide ions, and a great example of this is ammonia. Now you notice in this example here, ammonia is reacting with water. It is pulling one hydrogen off of water, making ammonium and hydroxide. So you put this into water, it will increase the concentration of hydroxide ions. But it does so very weakly. You notice the double arrow, the forward and the reverse reaction. This does not go to completion. This is considered a weak electrolyte, therefore a weak base. Now to understand how ammonia does this, we need to take a look at the structure for ammonia. Remember that ammonia is a tetrahedral compound with a lone pair. It's this lone pair on ammonia that will rip off a hydrogen from water, producing ammonium and hydroxide. But this isn't the only example of a weak base. If we were to replace one of those hydrogens on ammonia with, say, methyl, or CH3, we make methyl amine. Once we dissolve this into water, even though this is a covalent compound, it will react with water, producing, in this case, methyl ammonium, and again, hydroxide ions. And it does so very weakly, but it does so enough to increase the concentration of hydroxide. We can also take the exact same compound, ammonia, and replace two of the hydrogens with ethyl groups, making diethylamine. Again, we still have that tetrahedral nitrogen with a lone pair. It's going to react with water. In this case, it's going to form diethylammonium and hydroxide. Now we see this tetrahedral nitrogen all over the place. For instance, mescaline. Mescaline, once dissolved in water, that one NH2 group is going to deprotonate water, producing mescaline ammonium and hydroxide. Cocaine has this tetrahedral nitrogen with a lone pair on it. It's going to react with water, producing a weak base. As well as other compounds such as aspartame, saccharin, LSD, as well as our base pairs in biology. So we have to update our list of weak electrolytes. So weak electrolytes include anything that's called an acid, that's not among these 7 strong acids, as well as amino compounds, ammonia, and anything that ends in an NH2 or an NH. These are obviously amines that will react with water to produce hydroxide.